Good afternoon, everybody again. And my name is Zhiqiang Cheng. I work on turf grass and landscape pest management, but I also manage the R4 program. That's why we did work on quite a bit on coffee leaf rust in the years. So I want to acknowledge first of my co-authors of the presentation, my former and current graduate students and postdoc and technicians, because this presentation will summarize our coffee leaf rust research for the last 4 years also. So it kind of involved a lot of people from my program. So let's go ahead. Oh, yeah. So acknowledge all the current and former lab members who, not everybody you see on the slide contribute to this particular presentation research, but we work as a team. So I want to acknowledge that first. By now, I guess everybody is very familiar with what coffee leaf rust is and the situation in Hawaii. I don't think I need to spend too much time on that. But yeah, we have this big deal now since 2020. And if you are a coffee farmer and you are probably more familiar than me in terms of the symptoms and how to stay on top of it, hopefully more or less. But this is the early stage of infestation, and the later stage become a lot more severe symptom, as you can see. So let's jump onto our research updates now without talking too much about the background information, because I guess everybody is aware of that already. So yeah, I am the coordinator of the UHR4 program, and we were a 4-man team, but now we are down to 3. But we are rebuilding the R4 team, and hopefully we get another person to come in and back to 4-man team again. So basically, some of you guys probably are familiar or heard about Julie and James. They have been here for a very long time, over 30 years. Julie actually retired back in 2024, end of 2024. So then I began to work on the R4 program since 2018, when the former R4 PI retired back then. So jumping directly into the updates. So as you can see, this is kind of like the starting point of our coffee leaf rust efficacy trials. We did actually the former PI and his team, including Julie and James, before, even way before coffee leaf rust came, or at least was confirmed in Hawaii. They worked on the residue experiments already. Just a little bit of background of R4 program. So for the R4 research data collection, we essentially collect 3 types of data. So the first one is probably the most important of, at least for edible crops, is the residue, because we want to make sure it is safe to use to apply the new pesticide onto the crop we try to protect. Second one would be the phytotoxicity, the crop safety data. And we want to make sure the new pesticides are not damaging the plants already themselves. And then apparently the efficacy, we want to make sure the chemicals, they work, chemicals or biopesticides or whatever, nowadays, that coming to the pipeline, and they need to be very effective. So we collect these 3 types of data. Before coffee leaf rust was confirmed in Hawaii, we already collected the residue data. So then there are some information to back up some of the later actions already. But in 2021, very quickly after coffee leaf rust was confirmed in Hawaii, we began basically 2 field trials. And this is the year 1 R4 coffee leaf trial. And we developed this in consultation with the manufacturer of chemicals and also the R4 National Center, R4 Western Regional office. And we come up with this list of treatments. So all of this, they were not registered in Hawaii back then for coffee leaf rust control. However, they have been used either at other parts of the world for coffee leaf rust control, or they have been used in the US on similar rust species. That's why you feel if anything that can be approved or effective to become available for farmers to use, this would be the list that we try first, right? So we developed this treatment list and run the efficacy trial. So then, to just quickly summarize what we found in our year 1 result, as you can see here, that I hope you can see my mouse, but here is the best treatment we identified in our year 1 R4 research, which is Axelia. So that's the 2 lowest line here. You can see this is the percentage of incidence. So we kind of typically say that, if you want to preventatively treat the coffee leaf rust, this needs to be under 5%, ideally, right? that's kind of what we are aiming for. So then the Axelia was very good, and Preaxor is also fairly good, not quite as good as the true systemic fungicide that we developed here. And this was our year 1 summary of the data. And then moving on to the year 2 of our R4 coffee trials, we repeated Axelia because we feel it is very effective, and we want to make sure the second year we are getting similar result. And also we included several new treatments different from the year 1 treatments. So we want to hopefully identify more effective treatments options for people to potentially use down the line in the future. So that was the year 2 coffee leaf rust control research that we did for the R4 program. And also in this 2022, we also did some other anthracnose and herbicide screening for coffee, but we are not going to spend time on that because I will focus on the coffee leaf rust data here. And second year, again, Axelia again showed the best performance in terms of suppression of coffee leaf rust incidence. And in this case, also we are seeing another very good, very promising treatment, which is Abound. So that is reflected here. So it was also able to suppress the disease incidence below roughly around 5%. So that's what we kind of aim for. And at the same time, I also wrote in collaboration with the Suzanne and the USDA folks on the Big Island, and also Andrea on the extension side. We had this SCRI project from USDA NIFA, and we began to work on additional treatments. So these are more kind of like exploration of new, probably far down the line in terms of immediately availability for the farmers, right? So we were also, we mainly focused on true systemic fungicides and also a couple of bio fungicides. So one of them is extract of a plant species, and another one is a bacteria strain that we were testing. And in this case, we had several people working on this 2-year field trial. And this is Lily. She finished a couple years ago. And in my current postdoc, have been involved with both of these 2 years. And also Nina is my current master student in plant pathology working on coffee leaf rust control. So we did both years of treatment research at Kona Hills coffee farm on in the Kona side. So in this case, we had 6 treatments and 3 replications. We actually had more than that, but technically we had 3 blocks. But within each block, as you can see, we had 6 plots, and within each plot, we had 6 individual coffee plants. But we were only taking data from the inner 4 coffee trees, try to kind of avoid the border effects between any 2 adjacent plots. Just consider those 2 border coffee trees as the buffer for between any 2 adjacent plots. And then we had this setup. We did this research in 2 years at the same location. And these were the treatments included in this particular field research. And there is only one overlapping treatment in our SCI coffee leaf rust project and our year 2 R4 research project, which is Abound, because Abound is showing kind of good efficacy, and we want to basically make sure that is the case in another coffee farm, and also in the more replicated research plot that we have been doing over there. So that was the treatment details, and we don't have to go into the application data and those kind of things. But we had 5 treatments in this particular research, and we were looking at 2 types of data, 2 variables we collected: incidence of disease and also the severity of the infection. And so basically from 0 to 5 is on a scale system, and so this is also consistent with other published literature in terms of coffee leaf rust infestation level. So we want to hopefully be able to compare our results to the published literature as well. And we were also looking, try to observe potential phytotoxicity, and we did not see any. So to summarize this 2 years research for the SCI project, and as you can see in this overall presentation, in this overall graph. So in this case, Abound was the best treatment among all these treatments we tested. This is the year 1 data from June to May 2023. And this is the percentage of incidence. And similarly, when we look at the rating system, and so also Abound was the best treatment across. Sometimes you don't necessarily have the significant difference, but overall the trend, the pattern is Abound was the best treatment identified so far. And people have always, kind of hoping for biopesticides in this case or biocontrol agents, which is great. But in this case, at least for the two that we tested, they did provide some suppression in terms of incidence percentage and also the overall severity of the rating system. However, they did not last as long as the best treatment that we identified, or they were not quite as effective at any given point, pretty much compared to the chemical treatment that we identified. So second year that we basically repeated the same treatments exactly the same way. And so we were getting essentially very much similar message that Abound was the best treatment among all these treatments we identified. So you see that, overall, after a certain time in the winter time or early springtime, the overall incidence and the severity dropped. So that was not because all of a sudden all this treatment become very effective. It was mainly because of a lot of leaves dropped from the coffee plants, and that interfered with our, the true actually reflection of the treatment effects. But overall, as you can see, in this case, Abound was the best treatment identified. So to quickly summarize, we identified these two true systemic fungicide, which we still don't have any true systemic fungicide available for farmers to use here legally here in Hawaii. They were very effective against the coffee leaf rust in our multiple field trials. And although both biological fungicides tested were giving us some efficacy, but they were not quite as effective as the two systemic fungicides that we identified. They also did not last long in terms of the efficacy. So this we did provide. Okay, so now we have these two options for people to potentially use in the near future. But a quick update on these two, products. So Axelia is further down the line. So that means it will likely be available for people to use sooner than Abound. Axelia has been submitted to EPA for the Section 3, which is registration at the national level for people to use. And once that is approved, so that will trickle down to the state of Hawaii agriculture, and they will also approve the label, this particular product for people in Hawaii to use. So that is further down in the line. So I would probably imagine that maybe, hopefully later this year, this can become actually available. And I was before this presentation, I checked yesterday, and it was not registered as at the federal level, which is Section 3 level yet. So it's not finalized, the system. Once it's in the EPA's hand, it's out of our control. What we can do is we provide the data to support the potential registration. It will ultimately, based on the needs of the manufacturer, whether they see this is so there's a essential need for this product to be labeled for certain things. So then they can pursue the registration with EPA at the federal level. And Abound is kind of like will come later after Axelia. And so most likely Axelia will be available sooner than Abound. But these two, nonetheless, they are not officially available for people to use, but we provided the information for the manufacturer to pursue the registration. So ongoing research in my lab currently is we finished. I call all those R4 trials and SCR trials my kind of like a phase 1 coffee leaf rust research, because they were mostly focused on the field research conditions. And the ongoing one, we are looking at additional treatments, potential treatments, first in lab assays, and then in greenhouse small experiment setting. And then based on those results, we will be setting up additional field research later in the near future. So apparently, as you can see, we come up with this additional list. Maybe there is one or two overlapping, but in general, we have not tested most of them in our previous field trials. And we were trying to include additional biofungicides or biopesticides in general, but we were not successful in terms of obtaining some of the treatment materials. So then we kind of, okay, so we cannot wait forever, and let's move on with this new set of lab assays. So we did lab assays, and this is again Nina, who is handling all these lab assays and getting ready for the greenhouse study. So to make a long story short, we run this lab assays twice, and we identified that these few products, this I believe 5 treatments, were giving us very good, spore germination suppression. So these are the treatments. This is the control, and these are the treatments that were not effective in terms of suppressing the inhibiting the spore germination. But these treatments, we want the bar to be low. Yeah, so that means it suppress a lot more, spore germination. And these treatments were reflected in this list. And then we will conduct the greenhouse study based on these few treatments that we identified from the lab assays. So Nina is building this structure. So in order for coffee leaf rust to successfully establish on coffee plants, it needs a dark time and also a high humidity environment. So she's building this structure. It's not ready. This is nothing, it's going to look differently from this, but essentially building a kind of like a chamber-like system, and to hold the humidity and to block the sun, block the light. So then the rust needs that period to be able to establish on the coffee plants. Once that is conducted, and then we will be applying the treatments in the greenhouse setting using the list that we prepared from based on our lab assays. And then further down the road, once we finish the greenhouse study, if any treatments remain very effective, and we will include those treatments in a new field trial in the near future. And also, this is going to be later this spring. So that's what we have been doing recently in terms of coffee leaf rust research. So what else we don't want in Hawaii in terms of coffee pests in general? So then I was in this R4 national meeting back in 2023. Now, thinking it is already 3 years ago, can't believe that. But it was in Puerto Rico, and we visited the coffee farms over there. They had everything. They had CBB, they have coffee leaf rust, they have coffee leaf miner, in their opinion. So this is way worse, way severe, more severe insect pest compared to CBB. I asked them, how do you guys manage CBB? So a lot of their small farmers were saying, oh, we just take 20% loss from the berries. And but for coffee leaf rust, they apparently spend a lot more effort and resources to control that. But in their opinion, coffee leaf miner is a more severe pest compared to CBB and other things, potentially. Their opinion on that. And also coffee berry anthracnose, we don't have it here, but it is widespread over there. So these two are potentially, coffee pathogen and insect pests that we definitely don't want them to be here. But there's no guarantee because the quarantine effort can be only so much, right? So that's what I took away partially from that meeting, and also visit in Puerto Rico for their coffee industry over there. So I have a standard disclaimer because I deal with a lot of pesticides, and also acknowledgement for funding agencies and also other lab members and the collaborators, and also the farms where we were allowed to conduct these research trials. That's all I have, and I am open for questions if there are any.